Last week we discussed inscribed angles and inscribed polygons. Today we're going to talk about other types of angle relationships that occur within circles. So the first thing that we're going to talk about is when you have a tangent and a chord that intersect at a point on the circle. So if you look at this first diagram, hopefully you can see that, let me get a color, it's not here. Right here at point A, that tangent and chord AB are intersecting right there at point A. So that means they're intersecting right on the circle itself. When that happens, the measure of the angles that are formed are half the measure of the intercepted arcs. Just like when you had inscribed angles, the angle was half the measure of the arc. So in this diagram, angle 1, which is marked here in red, angle 1, the whole way, there we go. That's going to be half the measure of arc AB. And then angle 2, which I will mark in blue, get 2 arcs there because it's not the same measure. It's going to be half the measure of the arc BCA. Okay, so very similar to how intercepted angles worked last week. So in example 1 here, we're told that line M is tangent to the circle, and we can see that it is intersecting with chord AB right here at point B. They want you to find the measure of the red angle or arc. So in example 1, part A here, the red would be angle 1. So that is this angle right here. And that corresponds with arc AB. Now you're given the measure of arc AB to be 130 degrees. So that means to find the measure of angle 1, you're going to divide that by 2, angle 1. So if I do 130 divided by 2, I get 65 degrees. Remember, we are still talking about angles and arcs, so degrees are necessary. Please make sure you are option K'ing your answers to get a degree symbol. In example 1, part B, again, the same directions apply. So M is a tangent to the circle, and we can see it's intersecting chord KL right here at L. Now what they're asking you to find is they're asking you to find the measure of this arc, because they want the red one. The angle that is associated with that arc is 125 degrees. So to find the measure of arc KJL, notice there are 3 letters here to name this because it's bigger than 180. We're going to take the measure of that angle, which is 125, and we're going to multiply it by 2. So the measure of arc KJL will equal 250 degrees. Again, option K, your answers. Arcs and angles must have degree symbols. Moving on to the next type of angle. Very similar. Example 2 here. The next type of example is very similar. Example 2, they want to find the measure of X, where we can see that X is this angle right here. Okay, the intercepted arc that goes with that is this 228 degrees. So if I'm trying to find the measure of that, we know that it is the arc divided by 2. We cut it right in half. So that's going to be 114 degrees. Again, you must option K that. If you want to pause the video and try example 3 yourself, feel free to do that and then come back to see if you get it right or not. So example 3, we're trying to find the measure of this major arc, which corresponds with this angle here, which is 118. So to find the measure, it'll be Y in this case, we're going to do 118 multiplied by 2. So it's going to be 236 degrees. Again, you must have the degrees because arcs and angles are measured in degrees. So when you have tangents and chords and things intersecting, there are 3 different spots that they could be intersecting on the circle. Example number 1, if we have a circle, pretend that that's a circle. Actually, let me get a circle. I don't know how to do that. Okay, never mind. Sorry. So we have a circle. We've got a tangent, and we've got a chord. It could be intersecting right on the circle, just like the ones that we have just talked about. That's option number 1. Option number 2 for where these could be intersecting is they could be intersecting inside the circle. So here I have 2 chords, and the intersection is highlighted right there. That takes place inside the circle. So we'll get to what happens when they intersect inside the circle in a minute. The third place that they could intersect is they could intersect outside. Now these would be secants. Okay, these guys are intersecting right here. Oops, let me get the highlighter, sorry. Right here, which is outside your circle, which again we will get to in a minute. So I just went over what happens when they intersect on the circle. The angle is half the measure of the arc. Moving along to the other 2 situations. Okay, so in this one, let me kind of zoom in a little bit so we can see it better. If 2 chords intersect inside the circle, so this is what I promised we would talk about next. The measure of the angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. That sounds like a lot of words to me. So really what that means, if we look at this diagram, you've got angle X here. Well, the arcs that would correspond to that would be arc GR and arc TE. So kind of if you draw a line through it, it's the arcs that it hits. So the measure of X is going to be 1/2 the sum of those 2 arcs. So you're kind of averaging those arcs together. So let's do it with some numbers so it makes a little bit more sense. So example 4 here, they want you to find the value of X. So X is right here. So again, I want the arcs that are in line with that angle. So we have those 2 arcs. So right now I can see that arc KL is 156 degrees and arc JM is 130 degrees. So to find the measure of angle X, we have to add them up and take half of it. So 130 plus 156. So just do that math quick. We get 286 when we add them up. If I divide 286 by 2 or multiply it by 1/2, I get 143 degrees for X. And again, it is an angle measure. You do want degrees on that answer. Another example here, X is right here. So the arcs that coincide with that would be these 2 that I just highlighted, 63 and 89 degrees. So we're averaging those together. 63 plus 89. So if I add those together, I get 152. If I divide that by 2 or multiply that by 1/2, I get 76 degrees. And again, this is an angle measure, so I do want degrees. The other spot where we could have secants, chords, tangents, what have you, intersecting is outside of the circle. So if they are intersecting outside, looking at this diagram, you can see right here we're intersecting outside the circle. You're going to take half of the difference of the arcs that are formed by that. So in this case, you'd be taking this arc and this arc, subtracting their measures, and that gives you the measure of that angle. So again, we'll go through some examples with numbers so it hopefully makes a little bit more sense. So here we have this angle. The arcs that are formed by that angle would be these 2. Okay, so if I am plugging into this formula, we know it's going to be half of the difference. So the larger angle is the larger arc is 178. The smaller one is 76. We know we cannot have a negative angle measure, so I always put the larger one first. 178 minus 76 is 102. And if I divide that by 2 or multiply that by 1/2, I get 51 degrees. Again, you do need degrees for that angle measure. If you want to pause the video and try the next one, feel free to do that. And then come back and see if you get it right. This one does have a little bit of a twist to it, so it might be a fun thing for you to try. All right, so in example 7, now we're trying to find the measure of this arc. So the arc completely across from that is the 95 one, which means the angle that we're going for would be this one here, right in the middle. One problem, that leaves 2 unknowns. So what we want to do is we want to use this additional piece of information. So I know that this angle to the right is 102. We'll notice that the green angle in the middle that I marked and the 102 together form a line. Hopefully you remember that a line is 180 degrees. So what I'm going to do is I'm going to subtract out the 102 degrees that I have to get 78 degrees. That is the measure of this angle right here in the middle. So if I know the angle measure, in order to find that, we did half of the sum. Because we intersected inside the angle. Okay, so I'm just using the formula from the top of this page. And now we kind of have to work backwards a little bit. So in order to get rid of this fraction, I'm going to multiply both sides by 2. So if I do 78 times 2, I get 156. And then to get y alone, I'm going to subtract the 95 over. So I should get 61 degrees for the measure of that arc. And again, arcs do need degrees. All right, this last example here, move down just a little bit more. Now we are intersecting outside the circle. Okay, so we're intersecting out here. So we are going to find half of the difference of these 2 arcs that are formed. So to find x here, I want half of the difference of my 2 arcs, 78 minus 42. If I do 78 minus 42, we're going to get 36. If I take half of 36, we're going to get 18 degrees for the measure of that angle. The formula sheet, which is still available on Schoology, does have all of these relationships on it. So if it helps you to have a printout of these formulas or something like that, feel free to print out that formula sheet and use that for your practices. Let me know if you guys have any questions.